G'day everyone. What we're going to be doing this series of videos, and there's going to be a series of videos all relating to the same topic, and that is fuel. We are going to have a look at how fuel is produced, in other words, how it is manufactured. We're going to be using wood as an example because for thousands of years it's been used for heating and cooking around the planet. And we're going to stick to that pretty basic, simple formula for a start, and then we're going to further go into what hydrocarbons are and that process, which is going to be a little bit further down the track. But initially, we want to go through the process of understanding how fuel is manufactured, and we're going to be using wood as an example. So we're going to travel out to a place called Walpole and walk along the treetop walk. They've got a treetop walk out there where you can actually walk up in the canopy of the leaves and just get an appreciation as to how that canopy is responsible for manufacturing every part of that tree, whether it be part of the root system, the trunk itself, or even the leaves right out on the very ends. And that initial going through the tree canopy walk is then going to be followed on with the fact that we'll come back home, have a look at and digest that material that we've actually just had a look at, and then investigate how the tree is actually manufactured. And then what we're going to do in the next series of videos after that is we're going to go through the process of what actually happens when we burn the wood. So we're going through the growth of the wood, letting it dry out, and then burning the wood, and just see what combustion is. So initially we want to have a look and see what fuel is, and then what we're going to see is how that fuel has now been used to heat us up or generate light or whatever it might be used, but what chemical reactions are actually taking both of those cases. So we'll kick it underway. We're going to go out to Walpole next, and then we'll come back home and have a look at and digest that understanding of what's going on in that tree's canopy, and then we'll go through the next phase, which is going to be burning the wood.
We're here just out of Walpole in the southwest of Western Australia, not far from Albany where I live, and we're actually out at what they call the treetop walk. And this treetop walk looks at what the tree, we're up in the canopy, and the canopy is the building blocks for the tree itself. This is where all the action takes place. The leaves are manufacturing the whole of every part of that structure of the tree, from the root system all the way up through to the branches right at the very top, and even the leaves themselves are manufactured up here. So most of the tingle trees that we are looking at are native to Western Australia, and they are in the vicinity. These ones here, the oldest ones in this region, are around about 450 years old. So we're just having a look at the top perspective, looking at the canopy down, and this is where all the action takes place. Like I say, the distance down to there, these tingle trees can get up to 75 metres, but the kauri trees, which are also in the same area, can get up to 90 metres. So, and they, like I say, they're all around about 450 years old, which means they were here well before the first white person set foot on Australia. And it is good to see it looking from the tree's perspective in relationship to what's going on. So we go down the bottom and have a look from the bottom up.
Okay, we're back home now, and what we want to do is, I've got a photograph of the internet of a tree taken from its side, and we're just going to use this photo just to be able to go through and show you the process of what actually happens. We've had a look at the canopy and what is actually happening at the top levels of the tree. What we're going to have a look at now is what happens from the root system all the way up through to the structure in between. So for years and years, I was sort of under the impression that tree, if you were to measure the amount of material that was contained within the tree, there must be a huge percentage of that tree that has been made from the soil itself. If you get something like a 10-ton tree, there's going to be 2 or 3 tons of that tree manufactured from product that was used to be within the soil itself. As it turns out, that's 100% incorrect. 99% of most plant material is actually made from two fluids. Now, fluids can either be gases or liquids. One of them is a liquid, and that is water. So water is drawn up through the root system, up through the main branch or main stem, then it passes out through to the branches, right out and makes its way eventually out through to the leaves themselves. The other one is a gas, and so fluids can either be gases or liquids, and in this case air is a gas. Contained within the gas itself is carbon dioxide. Now, when I was born in 1959, there is 0.026% carbon dioxide. Very little amount of carbon dioxide in the atmosphere. But over time, that has now increased to 0.04% carbon dioxide, which is still a very small amount of carbon dioxide. But that is by far one of the biggest contributors to allow that tree to turn into the tree itself. So if we have a look at the leaf itself, I've got a side view here of a leaf. Now, all leaves are pretty similar in the fact that they contain the same ingredients. The very top part of the leaf is called the cuticle layer, and that allows water to bead off the leaf and fall onto the ground. Then we get our upper epidermis, and then we've got our palisade layer, our spongy mesophyll, and our stomata, and then our lower epidermis. Now, this is a really porous system. So the leaf itself allows air to breathe in and out. What it's doing so is the chlorophyll that is contained within the leaf itself is made from some of the trace elements out of the soil. Those trace elements include magnesium, and that is used within the chlorophyll to allow chemical reactions to take place. The other big influence that has got a part to play, a massive part to play, is sunlight. So sunlight is coming in and hitting the surface of that leaf, and that is creating the chemical reaction that is going to be generated within the leaf itself. So as the carbon dioxide is drawn up through into the leaf itself, the carbon is grabbed hold of by the chlorophyll, and the oxygen is released out into the atmosphere. What we can't see in this little example here is at the same time water is also passing out and is filled up in this gap here. Now, the hydrogen from the H2O is also grabbed hold of, where it joins forces with the carbon. Now, the hydrogen and the carbon create a hydrocarbon structure that is a solid. Remembering carbon dioxide is a gas and H2O, water, is a liquid. They are joining forces to create a hydrogen and carbon structure that is either going to be distributed off back through the root system to be part of, or through the branches, to create a new part of the root system, or another leaf, or a branch, or something like that. So the whole of that tree there is actually made from a hydrocarbon structure that used to be carbon dioxide and H2O. Now, when we have a look at what is actually happening, is the oxygen from the carbon dioxide and the oxygen from the H2O are both released into the atmosphere, where they can keep that continuous ratio of about 21%. What I've got is I've taken a leaf out of the fish pond and just have a look at the structure of the leaf itself in a little bit more detail. It's quite interesting to see that this vein system, this network of veins within the leaf itself, is really quite complex. When you're having a look at how that water is distributed evenly throughout the leaf, it has been drawn up through capillary action, and we're going to be looking at another series of videos on how that system works. But we can see that there's an even distribution of water being evenly distributed around that leaf itself. So that's where the water is able to be drawn up, where it joins forces with the carbon from the carbon dioxide. So that's a basic overview. We saw it from the tree canopy. Now we're looking at it, what actually happens from as a nuts and bolts sort of perspective. And water and carbon dioxide are generated and create 99% of that solid structure of the tree. So what we're going to do is go through the process next as to what happens when we chop that tree down, allow it to dry out, and then over a period of time the moisture has been now lost, and so we're ending up with a hydrocarbon structure that is now fuel. And so we're going to be going through the process in the next video of burning some of this wood and having a look at the chemical reaction that takes place as we do burn that wood.